Hi guys, this lesson's on solving equations. It's a very important lesson because for the rest of your mathematical career, whether it lasts through high school or on into college, you will continue to solve different types of equations. So we need to see what it looks like when an equation is solved in 7th grade. When it's solved, you're going to have your variable alone on one side of the equal sign, and it's going to have a coefficient of 1. Whether you can see it or not, if the letter is visible and there's no other number there, it is a coefficient of 1. So it's going to look like these. X equals 2. The variable can be on the right side of the equation. Negative 3 equals R. It can be rational. 5 and 2/10 equals Y. Or M equals 2/3. In each of these instances, the variable has a coefficient of 1. Even though you can't see it, it's there. So I have a few general rules that might help you as you're solving equations. The first one is you need to simplify both sides of the equal sign. So cover up the right side and look just at the left and see if you can combine like terms. It might even have a distributive property. And then cover up the left side and just look at the right and try to combine like terms on the right side. Then you're going to start on the same side of the equation that has the variable. So you got to find your letter. Remember, we are finished when I get the variable isolated or by itself, so we're going to remove any numbers that are on the same side with the variable. And we do that by removing what's furthest from the variable first. I'll show you what some of those look like. How do you remove it? You remove it by doing an inverse operation. The inverse of addition is subtraction, the inverse of multiplication is division, and vice versa. There are also some options that you're going to have, and I'll show you some of those as we solve them too. For instance, you could subtract to get rid of addition, or you could add the opposite. If I'm trying to get rid of an added 7, I could subtract 7. Or if I'm trying to get rid of a 7, I could add a negative 7, because either one of those operations gets me back to the identity of addition, which is 0. For multiplication, I can, if I have multiplication to a variable that I'm trying to get rid of, I could divide by that number. But remember, I'm trying to get a 1 coefficient, so watch your signs. Some of these can be a little tricky. Now remember, these are equations. So equations, when they come to you, are already balanced. And if you subtract something from one side of the equation and not the other, you've messed up the equality. So I have to be sure that whatever I do to one side of the equation, I do to the other. You could multiply by 4 billion on one side of the equation, and as long as you multiply by 4 billion on the other side, then you've not messed up the equality. Then we continue until the variable is isolated. That means it's alone on that side of the equation. We're going to start with some one-step examples. The first one says 2 plus x equals 9. Now what I generally like to do is to draw a line vertically through the equals. It helps me remember that my variable's on the left side, the 2's on the left side, the 9's on the right side. Sometimes students have a hard time, first of all, just keeping the equals above each other, and if you draw the line, then when you have to rewrite rows, then you're going to know exactly where that equal sign goes. Plus, you'll know which side the variable's going to belong on when you finish. And it's really important when we solve inequalities that you maintain the left side to the right side. So I need to get x alone. To do that, you can see the 2 has been added to it. Now you'll notice the number in front of 2, the sign in front of 2, is not visible. So then I know it's a positive 2. So how do I undo an added 2? You could subtract 2, or you could add negative 2. I'm going to decide to subtract 2. So if I subtract 2 on the left side of the equals, I have to jump over and subtract 2 from the right side. 2 minus 2 is 0, and it's just going to leave me x on the left side. And the right side, 9 minus 2 is 7. So my variable, the representation of it is 7. Now, how do I know if 7 is the correct value of x? I can check equations. That's what's so powerful about equations. You'll always know if it's right before you turn your paper in if you check them. If I think the value of x is 7, I'm going to rewrite the original problem, take out the x, and insert the 7. And then I'm going to work the left side. 2 plus 7 is 9, and truly 9 equals 9. Okay, this one is a multiplication problem. 1/5 m equals 9. I have 1/5 m equals 9 again, and I need to get m isolated. I have multiplication with the 1/5 and the m, so I have a couple of choices. To undo multiplication, you could divide by 1/5, but I could also multiply by its reciprocal, because either one of those operations will leave me with a 1 in the coefficient with the m. So this is what that looks like. The reciprocal of 1/5 is 5/1. So whatever you do to one side, you have to do to the other side to maintain the equation. Now you'll notice if I multiply 5, I'm doing the red 5/1 times the blue 1/5. 5 times 1 is 5 in the numerator, and 1 times 5 is 5 in the denominator. So if you have 5/5, that's another form of 1. So you'll be left with 1m on the left side, which is what I wanted. And on the right side, 9 doesn't have anything in the denominator, so assume it's a 1. 9 times 5 is 45, and you're going to be finished. So I think the answer is 45, but I can always check it. So I'm going to rewrite the original problem, and I'm going to take the m out, and I'm going to insert the 45. Now evaluate the left side. 1/5 times 45 is 9. 9 does equal 9, so it checks. This says c divided by -2 equals 6. I'm going to rewrite this problem so that it looks like something I can interpret. Did you know that you could take the fraction and separate the fraction times the c? It's still the same value. C divided by -2 is the same thing as -1/2 times c. The coefficient to the original c was not visible, so I knew it had to be a 1. So I just separated the fraction from the variable because now I see that I could multiply by its reciprocal. I could multiply by -2/1 on both sides like I did on the previous problem in the red. Or I can say, well, it's just multiplication, so let me divide by -1/2 on both sides. You have to divide by negative because a negative divided by negative is the only thing that will leave me with a positive 1. So 1c equals -12. I'm going to check it, take your original problem, take the c out, insert -12, and -12 divided by -2 is 6. 6 equals 6. Now we're going to move on to some two-step equations. These are called two steps because it takes two operations to arrive at the answer. I have 5m minus 9 equals 4. So I'm going to draw my wall. I need to get rid of the 5 and the 9. Those are on the same side with my variable m. So I have to remove them, and I need to choose one to move first. So remove what's furthest from the variable first, and that would be the 9. 9 subtracted, so I'm going to add 9 to both sides. -9 and a +9 go to 0, and it leaves me with just the 5m. On the right side, 4 plus 9 is 13. Now to get rid of the 5 that's with the m, it's being multiplied, so I'm going to divide by 5 on the left and on the right to keep it even. If I divide, I'll have 1m equals 2 3/5. So I got to check this to see if 2 3/5 is indeed the answer. I'm going to rewrite the original problem and take the m out and replace it with 2 3/5. Now you can check this on your calculator, that's fine. 5 times 2 3/5 is 13, and 13 minus 9 is 4, so it checks. This next one is a different look. It's a difference divided by 2. X minus 8 quantity divided by 2 equals -10. Now this time, what's furthest from my x? Can you see that 2's further than the 8? So I've got to remove the 2 first. Now that 2 is in the denominator. So what would be its numerator? You could think of it as a 1/2 since the 2's in the denominator. And I'm going to approach this like we did that problem previously that I fixed in red. I'm going to multiply the difference, x minus 8, by the reciprocal of 1/2. And that's 2/1. If that 2 in the denominator had been a 3, I'd multiply by 3/1. If that 2 in the denominator had been a 5, I would multiply by 5/1. Be sure you do that to both sides of the equation. Now when you simplify it, those 2's, one's in the numerator, one's in the denominator, so I can look at the x minus 8 as a quantity, and the 2 over 1 is another quantity that I'm multiplying, and I could do my cross simplification there. 2 and 2 share a factor of 2, so they divide out. 2 divides 2 one time. 1 times anything is itself, so I'm going to bring the x minus 8 down on the left side. Now on the right side, I don't have a denominator under the negative 10, so if you multiply negative 10 times 2 over 1, you get negative 20. So the only thing I have left now is to get rid of the subtracted 8. So I'm going to add 8 to both sides. Negative 8 plus 8 is 0. I'm going to bring my x down. Negative 20 plus 8 is negative 12. I think my answer is negative 12, but let's check it to be sure. If I insert the negative 12 in the parentheses for the x, negative 12 minus 8 is negative 20. Negative 20 divided by 2 is negative 10, so it checks. Have some more two-step equations. Okay, this one looks like a one-step, so why would I call it a two-step? Let's see. I'm going to start by getting rid of the 8. Guys, I'm afraid you might look at the 8 and try to add because you may interpret that subtraction sign to be with the 8 and it's not. The number's sign is always in front of it. So 8 had nothing in front of it, so I know it's a positive 8. And it's separated by that subtraction. I know it's not a multiplying problem because if it's either got a subtract or an add between the variable and the number, then it's not multiplication or division. So I'm going to subtract 8 from both sides. 8 minus 8 is 0, and I bring down the negative m. And 4 plus negative 8 is negative 4. I changed the subtraction to adding the opposite just to show you can. Subtracting 8 from a number, subtracting 8 from 8 will give you the same thing as adding negative 8 to 8, because 8 plus negative 8 is 0, or 8 minus 8 is 0. So I'm bringing down my negative m. The number that's with my negative m is a negative 1m. If you don't see a number with a letter, there's a 1 there. Negative 1m equals negative 4. It's squished together being multiplied, so I'm going to divide both sides by negative 1. On the left side, negative 1 divided by negative 1 is, that's right, positive 1m. And on the right side, negative 4 divided by negative 1 is a positive 4. So if you check this, watch your signs. I had the subtraction sign. I took the m out. I'm going to put 4 in, and 4 does equal 4, so it checks. Let's do another one. Negative 10 equals negative 1/4 m minus 9. Notice your variables on the right side. You still work it the same way. I have to get rid of the 1/4 and the 9, so I choose what's furthest first, and that's the 9. So to get rid of a subtracted 9, I'm going to add 9 to both sides of the equation, simplify, and I have a negative 1 on the left side. On the right side, all that's left is negative 1/4 m, because negative 9 plus 9 is 0. Now it's just a one-step equation. I have to get rid of that negative 1/4, and you have a choice. You could either divide both sides by negative 1/4, or you could multiply by negative 4 over 1, and that's what I'm going to do here. Negative 1/4, its reciprocal is negative 4 over 1, and that leaves me with a positive 1, because what you really have is negative 4 over negative 4, which is positive 1. But on the left side, negative 4 times negative 1 is positive 4. My coefficient to my letter is a 1, so I'm done. I'm going to check it, take the m out in the original problem, and insert a 4. So I'll have negative 10. Negative 1/4 times 4 is negative 1 minus 9, and negative 1 minus 9 is negative